Hello, YouTube.
Hi, YouTube.
How you doing? Okay. What are we doing today? What happened?
Just refresh the page.
Alright, okay? Everyone got a safe cell open? Alright, so we're up to BC4 today with Sage, so let's take a look at it. 2016 BC4 says, consider the differential equation dy dx is x squared minus 1 half y. Find the second derivative in terms of x and y. Okay, so what do? You know, this, I'm not going to do this in Sage because it's in two variables, and that's going to get too complicated. But we're just going to write down like a little note to self. You know, same thing happened to me, Lauren. Look at this. I can't click.
Yeah, that happened to me too.
I got it. No, it would have to be a diff, but a diff with two variables. I'm not going to get into that right now, but here, put your name on here, and put the date. What are we up to, the 6th? And the topic is 2016 BC4. All right, number 4A. Okay, so they're giving you y prime, or dy dx, is equal to... Hello, how you doing? Dressing normally, I see. Dressing normally, like every day. Okay, we're missing... Oh, safer. They can never give you this because you never hear at the beginning of the period. Yay. Congratulations. I don't know what it is. Oh. Okay. Well, at least we get that. Okay. All right. Okay, so we got x squared. Listen, shh. We got x squared minus 1 half y, right? All right, so just write that down. X squared minus 1 half y. How about this? Okay. So now I'm not going to use the diff command here for two variables because it's a production, so I'm not going to bother with that. But what would it be? What would you write? Dang it, squared. There you go. What would you write?
Wait, no, I think you did it.
I didn't do anything yet.
Did you mean D?
Oh, I did something weird. Yeah. Where's the 2? There. Okay. All right. So, what would you write?
It's 2x.
2x. Okay. Minus
1 half.
1 half.
X squared minus 1.
Okay, it's what? Right. It's 1 half. Let's see. I'm going to write this. It's going to be 1 half of dy dx, right? Because we're differentiating 1 half of y. But dy dx is given as x squared minus 1 half y. Right, okay, so one more little comment, note to self. We're going to need this later. We get this is the same as putting this here. How's that? All right, so that's our answer to part A. What is the second derivative with respect to x? There it is. Does that sound like something you might have done?
No.
No?
For sure not.
Oh, God. Oh, no. Make it stop. Okay. All right, so we're going to need this in part B. You got it?
See, I have no idea what I even wrote on the test. It was such a blur.
Really? You have no idea what you did?
It was, you know how PTSD just tried to forget it.
All right, so let's go to part B. Are you ready for part B? We're just writing down a comment for that one. All right, so this is the question, this is the work, and this is the answer. Yay. All right, so part B. Let y equal f of x be the particular solution to the given differential equation whose graph passes through the point -2, 8. Okay. Does the graph of f have a relative min, a relative max, or neither at -2, 8? Justify your answer. Now, since we have the first and second derivatives, why don't we use the second derivative test? What does the second derivative test say? Where the first derivative has a critical point, namely where it's 0 or undefined. If the second derivative is negative, it's concave down there, but you also have a horizontal tangent there if it's a 0 derivative. So if you have a horizontal tangent, the first derivative is 0, and you have a second derivative which is negative, so it's concave down, min, max, or neither. Visualize, if you will. You have a curve, right? With a horizontal tangent line at this point, yes? Plus it's concave down. That's got to be max. What if it's concave up? Got to be a min. All right, let's find out. What we have to do is evaluate dy dx at the point given. What was the point now? It was at negative 2, 8, okay? And, whoops, and the second derivative we just got. All right, so how about we just say this? Let's define, let's see, how about f prime as a function of x and y is what we were given, right? X squared over minus y over 2. Well, let's just write that down. Okay. And then f double prime as a function of x and y. Get used to this notation. You're going to be doing multivariate next year, aren't you? Okay.
No,
Is hopefully.
No, I had to redo calculus.
Well, we don't talk about those things. And okay, so that's really what we have, right? This is y dy dx that was given, and here's the d squared y dx squared that we figured out, right? Now we have to evaluate both of these at negative 2, 8, right? Okay, so let's show. Let's move this up a little bit. Move it up. All right, let's show f prime at negative 2, 8 they wanted, right? Let's see, what do we got there? Is it 0, undefined, or neither? And what I do? Error, what's the error? Oh, it doesn't know why. Yeah, but it doesn't say that, does it? Usually it says that if that's the error. I think that's what the error is. Yeah, I think that's the error. All right, let's var y. Var y. Well, the spaces are ignored. Yeah. No, it still doesn't like it. Why the hell doesn't it like it?
It's the space.
No, it's not the space. Stop it.
Oh, I spelled they, not var.
Why wouldn't it let me evaluate this? Wait, hang on.
Var x2.
I got 0.
You should get 0. Who got 0?
I did
What'd you do different?
I used 0.5s, not 1.
Oh, it's trying to do it exactly and
And you see how multiplication is not.
Oh, that's my error. I don't. Oh, yes. Sorry. Did I just hit you? Did you live? Did you live?
What's going on?
Oh, yeah, my mistake. Sorry. That's the error. Remember what we said, that multiplication is not implicit. I don't need it there because it's a comment, but I need it here. All right. There you go. That's probably it. So I don't know if I needed the var y. I guess we did. There you go. 0. Perfect. All right. All right. So now what did we say? Where we have a critical point, if the derivative is 0, then if we have also the second derivative is positive, we have a min, or if the second derivative is negative, we have a max, right? All right, so let's evaluate the second derivative. What do I write? Show FPP negative 2. Are we too old for that, Henry? And it's negative. Aha! So what does the second derivative test say about this? Where the heck did my page go? There it is. Well, since there's a horizontal tangent there, f prime is 0, and the second derivative is negative, right, concave down, it's got to be a max there, yes? Okay, so let's write this out. All right, so let's write the answer. Okay, listen. Shh. F of negative 2 equal 8 is a relative max by the second derivative test. Okay, all you have to show was that f prime was 0 and f double prime was negative, and we did. Alrighty. Any questions how we did B? All right, as long as you show that f prime is 0, we did, and f double prime is negative, so it's got a horizontal tangent line and it's concave down, you have a max. Okay. Any questions how we did A or B? That's A and B. Questions, comments, problems? If you're missing anything, look on with your neighbor. If I go too far ahead of you. All right, part C. Are you ready for part C?
Yes.
Hang on. Oh. All right. No. We have not yet begun to fight. What are you talking about? Okay.
You gotta surrender before you
No, surrender nothing. All right.
More than 700 views.
Can you get 1,000 now?
I'm waiting for Paris here.
You know, like, it gets stuck.
You can look on with Safer, right? Safer, you got everything? Yes, you can look on with you? Okay. All right, so let's continue. Boom. All right, part C, listen up. Shh. Listen. All right, let y equal g of x be the particular solution to the differential equation such that g of -1 is 2. Find the limit as x goes to -1 of g minus 2 over 3 times x plus 1 squared. So, how do you do this? Is this a plug-in limit? Is that a plug-in limit? Plug in -1, what do you get? Well, g of -1 is 2, so you get 0 over 0, don't you? So that's L'Hopital. All right, so what does L'Hopital say to do? Derivative of the top over the derivative of the bottom, right? Okay. Now, the derivative of the top... Let's see. Yeah, hang on. All right, so let's talk about this. Here we go. All right, so part C. We want to take the limit of g prime How am I going to write this? All right, let me just say, all right, this is what we're going to do. We're going to take the limit of g prime over, all right, well, by the way, what is the derivative of 3 times x plus 1 squared? 6.
Just 6x. 6 times x plus 1.
Right, so 6x was 6, is that right? Okay. All right, so the problem is, okay, let's just write this down. The problem is that this is also a problem. 6x minus 6. Isn't this also a problem? As you approach x equals -1, whoops, as x approaches -1, okay? That's what I want to do, right? But I can't do it because, well, hang on. How do I want to write this? Isn't g prime, in fact, this?
Yes.
Right? That's what g, in other words, this. It's f double prime. Okay, let me write it down here. Here we go. I'm going to write it down here. But instead of g prime, I'm going to write f prime. Alrighty. So, now, let me think about this. Hang on. Can we take that limit? I don't know. This is also two-variable limit. This is a problem. What does it do if I tell it to do that? Yeah, it doesn't know what y is. Yeah, but what's y doing? As x approaches -1, g of -1 is 2. Can I put two limits here? Y equals -2? Wait, was it -2? It's positive. It's positive. No, I won't do that. Dang it. Yeah, I don't want to get into multivariate stuff here yet. There's a problem, though. All right, well, let's see. What does it say? If I show that, what's the problem with this? Is there a problem with this?
It's not a numerical answer.
Right, but we know that y is, what's y?
2.
It's 2. So what if you plug in 2 here? You get 0, right? You get 0 again. Okay. So, wait, this is weird. Something's weird here. If you plug in -1 on the bottom, what do you get? Don't you get 0 in the denominator? And if you plug in -1 in the numerator, There's something wrong with this. What? What did you write? That is weird. What?
Yeah, I got that.
You got the same thing? You wrote what I wrote?
Oh,
The limit of this as x approaches -1?
Yeah, all over 6. Oh, no, I did plus 6. 6x plus 6.
Oh, yeah.
Is it a -6?
It's minus 6, yeah.
Oh, wait, wait. It is +6. You're right, it is +6. I'm sorry, it is +6. Whoopsie.
Yeah, because I was copying and pasting.
Yeah, I was talking.
It is +6. Okay. That's what we get. Okay. All right, now, yeah, but that's better, because I was wondering why it was still, it was defined. This is also undefined, isn't it? Look, this is still undefined. Well, not undefined, indeterminate. This is still 0 over 0, isn't it?
Do it again.
Right, so we got to do it again. Right, but now, listen, look. What if we plug in -1 for x? What do you get here?
I got an error. How did you make it do that instead of the other?
Well, because I wrote a negative here by accident. It's plus. Right? Look what they gave us. The derivative of the denominator is 6x plus 6. Isn't it plus? Okay. Yeah, now notice this is still indeterminate. Whoops, you got that? Because if we plug in -1 for x here, you get what? Go ahead. Plug in -1 here, what do you get? 2. And they're saying that y is 2, so 2 minus 2.
0.
And plugging -1 here,
You get 0.
you get it's still 0 over 0 case. So, L'Hopital. So what's the derivative of the bottom? 6. What's the derivative of the top? We have a name for it. F double prime, right? Okay, so let's rewrite this. We'll make it F double prime over 6. In fact, I guess I don't need all these parentheses. And now we get what? Well, yeah, remember we have to plug in our y. All right, so did you get that?
Wait, just purely over 6 now.
Yeah, it's over 6 because the derivative of 6x plus 6 is 6. The derivative of f prime is f double prime. But we have to plug in our own 2, right? So what our own y, which is 2. So what do you get? 2 24ths is 1/12. 1/12 minus 5/12 is -4/12. So -4/12 is -1/2, and there you go. I'm sorry, -1/3, right? -1/3, yeah.
Wait, I got in decimals. How do we change that?
Well, you must have a decimal. That's okay.
I had a 0.5 over here.
Yeah, you can plug in 2. What we could do is define that as a function of y and plug in 2.
Oh, no, I got a function. I got a fraction.
Yeah, but then if you want to plug in 2 in your head, it's not clear that this minus this is -1/3. No, so maybe if instead of putting 0.5, you put 1/2 with your head, it's more exact. Right? All right, so everyone got that far?
Can we print it down?
Almost up.
Well, have you seen Chad's bicep?
Yeah, this is a plus.
Is it written where the flags there?
Yo, Chad's not even
Yeah. I was considering running the version, but I was like,
Is your name Chad?
I wouldn't be surprised if you would have heard it from me.
Yo, Jay. Look at this middle guy. Look at the
I found straight fine velocity, like the golf swing.
You have the same
And
result?
I thought I was like, no, you can't. Like, this is really hard. And then he was like, okay, yeah, it's really hard.
Well, would that violate dress code if I did
Hear
it?
your own theme?
Wait, Tim. You guys
I mean, girls dress code on
Huh?
girls
No, the top. Like, all literally, like, he folded shit and, like, still from the
We didn't get the -1/3. Who's stuck?
I just really want to see his reaction.
Yeah, his reaction.
I was really.
I feel like kicks me out, so I get to go home. Because I have all 4th and 5th, so I hope 2nd grade kicks me out.
Well, what third?
Alright.
Oh, we're doing the egg drop.
Yeah, we're doing an 8 drop.
Anyone else stuck? Who didn't get the -1/3?
Okay.
Okay? Okay. I mean, if you wanted, no, we're not printing yet. Hang on. If you hang on. If you want to, if you wanted to, you could set this equal to f of y and plug into and get the -1/3 right away. I'm just curious. What if I did that? Hang on.
Curiosity kills the cat.
Yeah, the cat died a long time ago. So let's see. How about if I call this f of y, and then show f of 2, and hopefully that will give me the 1/3 directly. There it is. See? So I wasn't kidding. It is negative 1/3.
Are we doing that as well?
Wait, why am I missing that?
All right, so that limit is a function in y. As you saw, all we had to do was plug in something for y. So I made a function in y and plugged in 2, and I got the negative 1/3 just to show that it's negative 1/3.
I think
All right?
you could give me this during the test and I still wouldn't have it.
Sage
It's harder.
is as good, if not better, as the Inspire as far as the cast. It's got so much more capability to it.
Yeah, but I would.
Scrolling up there.
But you can't carry Sage in your pocket, now can you, Mr. Garcia?
Yeah, you can. I do it on my phone all the time. There's even a Sage app.
Oh.
You can make it so much worse.
Too much work.
Yeah,
You carry your phone everywhere. What are you talking about?
Keyboard.
No, whatever. All right, does everyone have all of this stuff? The bottom? Okay.
It was so trash, but it was cool. So I was like, wow.
All right, let's see. All right, one more part. Part D is an Euler method, right?
Hashtag 4D.
All right. Here we go. Ready? You got it? No? Well, Steven can look on with Delupe if she stays on task. That would be nice.
Oh.
Huh? I know you are, but he's got to see what you're doing because I'm leaving. Ah. All right, good. Okay, part D. Let y equal h of x be a particular solution to the differential equation such that f h of 0 is 2. Use Euler's method starting with x equal to 0 with 2 equal steps. 2 steps of equal size to find h of 1. Remember Euler's method? And now it's Euler. Okay.
Where do you see the O and the I, Mr. G?
Speak in German. Euler.
Well, why
His
would I
name is
speak
Euler.
such a dirty language?
EU is a special vowel. It's called a diphthong. Diphthong. It's a combination of 2 vowels. So now you have 6 vowels. Are you happy?
Your mind's always messed
Okay.
up.
All right. Shh. All right, yeah? As many as currently necessary. All right. Right, exactly. That's all we need right now. Okay. We speak Sage. Well, it's a language. It's Python. It's based on Python.
Have you seen the movie Lorca
Which version?
with Andy Garcia?
Oh, probably.
Jaime was in it.
Jaime, yes, Jaime was in it. Yes, I know. Yes, I think I've seen that. Jaime Escalante. Well, no, not Jaime. The actor for Jaime. Yeah. What is Edward James Olmos? Edward James Olmos. Yeah. Yeah, they did a lot of movies together. All right, so. All right. Okay, now remember how you do Euler's method. We have h of 0 is 2. How do we get h of 1 in 2 steps?
You go by 0.5.
You define h of x, h of y. You define the function, and then you show h of 2.
Okay, but wait, we don't know the function.
So
Would-
you said in 2 steps.
Right, how does Euler's method work in 2 steps, remember? You have h of 0 is 2. Right, then you take, all right, so if what's my delta x if I want to go from x equals 0 to x equals 1 in 2 steps? 0.5, all right. And then I'm going to take f prime, don't we have f prime defined? Times your delta x each time, and add it on to your y? All right, so how am I going to write this? Okay, so we know that h of 0, all right, how about this? No. Okay, this is what we're given, okay? We're given that h of 0 is 2, right? Is that what we got? Yes. And we have a delta x of 0.5.
How do I get a full screen?
How do you... F11? Okay. So how do you get f of 0.8... h of 0.5?
No idea.
Isn't that going to be f prime of... Now, of what? Of 0, 2, right? Is that where we are right now?
Yeah.
Okay, so 0, comma 2 times... Where's my times? Times what? What was your delta x? 0.5, right? And that's going to be my delta y, but I want to add that on to my current value of y. So what was my current value of y? 2. All right, so what's my first entry in my Euler table? 3 over 2? What? 3, yeah, 3 over 2, right. Okay, good.
It's a lag. Dude, we need some Google Files.
All right, so you see, this is, all right. Do you remember how we usually do this? We have a table for x, we have a column for x, a column for y, and a column for delta y, right? Okay, so my first y was this, my first delta y is this, so my next y is 1.5, right? Okay, so how do I get the last one? They only need to do 2 steps, right? How do you do the next one?
So we use our new y value.
Use your new y value, which is all of this craziness. I'm just going to, all right, but I'm going to just copy it. Plus what?
Plus f.
All right, let's not be crazy. What was it, 1.5? Okay, 1.5. Okay, plus fp at, now what's x and y?
The 1 point something. 0.5 comma
0.5 comma 1.5, perfect, okay. And then don't forget times delta x, which is 0.5, and we're adding it on to the current the current y, which is 3.5.
I thought it was 1.5.
The 1.5 was the delta.
Oh, yes.
Okay. Okay.
1.25.
Boom.
Hey, that's pretty good.
1.25 is that what we got?
Yeah. Wait, how did
I should have 5.2. Wait, what happened? What did I do?
You did 2 plus. Wait, are you supposed to do that?
Oh, wait. All right. It's the current y value.
Oh, okay. So
It's the current y value, which is 3.5, right?
It's 1 point.
It's 1.5?
Just solve for that in the, if you go to evaluate below.
Yeah.
We solved it at 1.5.
Okay, 1.5 plus
So if you
the new delta y, which
you
is
added extra 2 there.
I added too much stuff.
Yeah, you added extra 2.
All right.
Before now.
Shut up.
What happened? What is wrong with that? Oh yeah, 1.25. That's it. There you go. All right. Does everyone get 1.25 out of that one?
Yeah.
All right. So we're gonna say. So they want to know what h of 1 is, and it's 1.25. That's what they want. Ta-da!
Can we print now?
All right. So, are you ready to print? All right. Now, when you print, it's only going to show this much. It's not going to show you work after this, but it's going to show you all your answers, right? So, Control P, Enter. Go.
Wait, how did you get a 1? Wait, can you scroll down?
Yeah.
How did I get a 1
Keep,
plus
no. No, down. How did you go 1.25? This is a 3.25.
No, because this is the 1.5 we just got.
You added an extra 2 plus.
Yeah, I wrote this down wrong. Did you have 3.5 here?
Yes.
Yeah, it's 1.5. It's the current y, which is 1.5 plus that,
This is
right?
2 plus 1.5? Yeah. You said you added an extra 2 plus.
And I guess
It's
this.
2 plus 1.5.
So this had to have been a negative 0.5, right?
2 plus is 2.
And then this was a negative 1 quarter.
But is it wrong with what I just said?
All right, so if you're ready, Control P, Enter. Don't get it.
No,
You don't have to get it because it's gonna take a while. Well, that might take a while.
What I meant, you added an extra 2 symbol and a plus symbol.
All right, YouTube, that was fun. Bye bye.